Recent research has shown that empirical evidence for globalization of corporate innovation is very limited, and as a corollary, the market for technologies is shrinking. As a world leader, it's important for America to provide systematic research grants for our scientists. I believe strongly that there will always be a need for us to have a well-articulated innovation policy with emphasis on human resource development. Thank you.
Alright guys, I don't know if anyone's ever seen the movie Old School, but that was a scene where they're having a debate, and he responded with a very good argument. And as you kind of notice, the theme of this entire chapter is logic, working your way through problems, so I thought that was appropriate, and it made me laugh really hard too, so it's one of my favorite scenes of the movie. Alright, we're going to take a look today at 1.3 deductive reasoning, okay? And basically, we're just kind of building off of what we've been doing the past two sections, and a lot of this is going to be either just logic or using symbolic notation, okay? So we're going to begin the notes with this symbolic notation, and we'll talk about it. And it may look complex, but really all you're doing is a little bit of substitution, okay? So it's actually a little easier once you get the tricks down, so let's kind of dive in. Conditional statements can be written using symbolic notation, where P represents the hypothesis, Q represents the conclusion, and this little arrow pointing to the right is read as implies. Okay, so let's take a look at our first one, conditional statement. In words, if it is raining, then the soccer game is canceled. So in using symbols, if P, then Q, or P implies Q. This right here, your hypothesis is your P. Okay, now again, this is for one conditional statement, so this blankets every conditional statement. Over here, then the soccer game is canceled as your conclusion. That's your Q. Okay, and in turn, as we go through all these, that's all we're doing. Okay, we're replacing your hypothesis or conclusion with the P and the Q respectively. Okay, so converse statement using words. If the soccer game is canceled, then it is raining. Again, we're just flipping it around. So look how the symbolic notation works. If Q, then P, or Q implies P. This is one we're going to get to in about two sections. Okay, it's called biconditional. I'm going to show it to you real quick, but I don't need you to really know it just yet. It's pretty simple. It's called the biconditional. In words, if it is raining, if and only if. Okay, this is the difference. Instead of if then, biconditional is just if and only if. The soccer game is canceled. And we still use P's and Q's, but the difference here is we have this double-sided arrow because a biconditional is basically a true conditional and a true converse. All right, but again, we're going to get to this very soon. It's nothing complex. It's just if and only if. That's the only thing different. Contrapositive, when you flip and negate and using words, if the soccer game is not canceled, then it is not raining. Using symbols, if not P, then not, if not Q, then not P. Alright, so not Q implies not P. This right here, if anybody wants to take a note on this, you see this little squiggly line? That just is the negation. Okay. Inverse, which again is just negation of your conditional. If it is not raining, then the soccer game is not canceled. If not P, then not Q. Or not P implies not Q. Okay? So, coming down here, for number one, let P be the value of x is -4, and let Q be the absolute value of x is 4. So all we're going to do is rewrite these, okay? The first one says, write P implies Q in words. Here's your P. So the implies is if, then, all right? If the value of x is -4. Then the absolute value of x is 4. Oop, there we go. Okay, it's just replacing it. Again, it's just that idea of substitution, which you guys all know and love from algebra class. Right, part B, write Q implies P in words. It's just a converse, so I'm just flipping this sentence around. If the absolute value of x is 4, then the value of x is -4. Okay? I want to put one more on here just to add it, just because you're going to see it on your homework and it's not in the notes. If you see this, negation P, come up here to your P statement, the value of x is -4. If I want to negate that, okay, in words, I could write the value of x is not -4. Notice I didn't have an if and then in that statement, again because that arrow is not there. Okay? And let me show you one more as well while we're on the topic, that biconditional, the double arrow one. It's really simple. Write out your P first, just like you see it. The value of x is -4 if and only if. Then you write the second part. The absolute value of x is 4. Okay? So just to show you guys a little bit, a few more examples, I figured that would help you out. On to the back. Okay, we have for you guys 2 laws of logic, and they are just 2 basic laws that we take a look at that allow you to kind of rationally think through problems. The second one I think is easier. The first one is almost too easy that it confuses you. Yes, that's a thing. So let's take a look at them. The first one's called law of detachment. If P implies Q is a true conditional statement, and P is true, then Q is true. So like I said, this one's almost so simple. It's like almost like confusing. I hate saying it like that, but it's true. If Sean and Dan get dressed up, then they will be going to a party. Sean and Dan are dressed up, then they will be going to the party. They will be going to a party. Here's the important part about this one. If P, then Q. P must be true first, then Q is true. Okay, as we notice down here, we're going to take a look at an example where this might not be the case. Jamal, here, state whether the argument is true or false using law of detachment. Jamal knows that if he misses the practice the day before a game, then he will not be a starting player in the game. Jamal missed practice on Tuesday, so he concludes that he will not be able to start the game on Wednesday. This is true by law of detachment. By law of detachment. Okay, and let's examine this a little bit. Jamal knows he misses the practice before a game, then he will not be able to starting player in a game. So here's your P, here's your Q. Okay, P's first, Q's second. P is true, so then he concludes Q is true. That's how it follows up top here. Okay, that's our law of detachment. Now, for part B, if 2 angles form a linear pair, then they are supplementary. Okay, P, Q. Angle A and angle B are supplementary, so they're saying Q is true. So angle A and angle B form a linear pair, then P is true. This is false. It does not fit the pattern. And again, the pattern is just read it in order. 2 angles form a linear pair, that's your P, then they're supplementary. Angle A and angle B are supplementary, so they're saying the B is true, or the Q is true rather, sorry. So angle A and angle B form a linear pair, all right? That's all there is to it. Like I said, it's almost so simple, it's like confusing. It's all about that pattern, okay? Nice. All right, so this next one I think actually makes more sense just because it kind of falls in succession. Law of syllogism, if P implies Q and Q implies R are true conditional statements, then P implies R is true, okay? So it's kind of the transitive property, if you guys remember that. Again, if A equals B and B equals C, then A equals C. It's almost the exact same thing. So if you want to call this the transitive law, that makes sense as well. So let's take a look at our example. If Ken visits New York, then he will spend a day in New York City. If Ken spends a day in New York City, then he will visit the Empire State Building. If Ken visits New York, then he will visit the Empire State Building. Okay. So let's take a look at two example problems. I'm going to show you guys a little trick too that I use kind of in my head. Here, I'll show you back up top of the example. You see how he will spend a day in New York City, spends a day in New York City are exactly the same? What you can do is if you take a highlighter and kind of like highlight that out or just cross it out, whatever's left is your answer. Ken visits New York, then he will visit the Empire State Building. That's why I love this problem. The answer is like right there in front of you. So here we go, number 4. Use the law of syllogism, write the statement that follows from the true pair of statements. If the sun is shining, then it's a beautiful day. It is a beautiful day. Then we will. If it is a beautiful day, then we have a picnic. If I cross these two statements out, my answer is right in front of me. If the sun is shining, then we will have a picnic. Okay, perfect. And lastly, if Bob goes to a football game, then Sam will go to a football game. If Sam goes to the football game, then Jamie will go to the football game. So this idea of Sam going to the football game kind of trumps out, and whatever's left is your answer. If Bob Okay, so there are your two examples of your laws, law of detachment and law of syllogism. We will get some practice with it on the homework and of course in class go over it. Again, as always, if you ever have any questions, feel free to ask during class. I'm hoping this is clicking a little bit. Hopefully you're enjoying these videos. And most importantly, as always, good luck. We're all counting on you.